So we're going to start chapter 5 of our book, even though we're barely using the book. And it's still all trig stuff. I told you trig stuff to the end of the semester pretty much. We're going to be learning about identities today. So last year, I think maybe honors class hit some identities. My CP class did not get to any. So I feel like I was maybe further ahead than some Algebra 2 classes. So this is going to be new for a lot of you. All right. The first thing we want to talk about is, identities are things that are completely equal to each other. Like equal to each other. So the first ones we're going to talk about are just simple reciprocal identities. Sin u, when I talk about reciprocal, sin u is equal to what? What do we know about reciprocals and sine? What do you yell out when I say the reciprocal of sine? What? Or mean? Cosecant, the CSC. But they're not equal to each other. Like I can't say, don't write this down, I can't say sine theta equals cosecant theta. They're not equal to each other. They are reciprocals of each other. So to say that they are equal, to set them equal to each other, I have to say sine u is equal to 1 over cosecant. U is instead of theta. There you go. I should just go change that to thetas, but these are just like formulas, so they're using u instead of theta. Could be any angle. So using that, what would cosine u, reciprocal cosine u equal? 1 over secant u. The reciprocal of tangent, the reciprocal identity of tangent will be 1 over cotangent u. Can you try the next three, which are these bottom three? Did you not get them? Did you miss when I was like, who did I not hand it to? You missed that part? Okay. I didn't know if you missed me saying that or if you raised your hand and I missed you. Did everybody else not get one? Sorry about that. So 1 over sine u, 1 over cosine u, 1 over tangent u. Now I have this little example over here that says sine x multiplied by cosecant x equals 1. I'm going to verify with you right now that that is true. Sine x and cosecant x, what I'm going to do is I'm going to use a substitution property. I'm going to put, instead of cosecant x, I'm going to put what cosecant x equals, which is 1 over sine u. So I'm using the substitution property because these two things are equivalent. So I'm substituting. Oh, sorry, x. I'm confusing myself. X. Using x. Okay, now I am verifying that this equals 1. I'm not solving for anything. I'm just going to show you that it equals 1. So I'm going to keep working on the left side. I'm going to multiply together a whole number with a fraction. What do I do to that whole number to multiply fractions? You put it over 1. So when I multiply these together, I get sine x over sine x, which is what? 1. Do you see how I am verifying that this is true by only changing the left side of the equation until they are equivalent? We did something like that before when we were doing inverses and we were doing like f of g of x. And then we only like worked until we got equals x. Remember doing that before? Chapter 1. Okay. It'll be on your exam. So we'll have to go over it again. All right. There are other identities. Actually, there's lots of identities. Here's another one. These are called quotient identities. So this is different than a reciprocal identity. A tangent u is equal to two things divided. Now you guys are going to help me come up with this. when I say tangent and we're talking about the unit circle, we're talking about finding tangent, we always put what over what? And put y over x, right? And then on the unit circle, y is what? Sine. So tangent is the exact same thing as sine u over cosine u. This is a quotient identity. Okay? How about cotangent u? What's cotangent normally? Cotangent is x over y. So what's x? Cosine u over sine u. So these are equivalent. So those are the quotient identities. There's some other things I wanted to show you is what happens if we multiply sine x times sine x. If we multiply those together, it is sine squared x. Okay? You are going to write it a little different than you might suspect. This is how you're going to write it. I'm going to show you why using actual numbers. What's an easy one that we can do the sine value of? Sine of what? 30? Sine of 30. Okay. So sine of 30, if we're doing sine of 30 times sine of 30, what is sine of 30? 1/2. Almost 1/2. That'd be 1/4. Okay. So now on this side, this would be like you're going to have 30 for x. You're going to find the sine, and then you're going to square that sine. So that this is why it's written this way. We're not actually squaring the 30. We're squaring the sine of 30. Okay, because if I squared the 30, we'd be doing sine of 900 degrees, which is not what we're doing. What?
So why don't you just put it in parentheses?
We can, but we don't. That's too much work. Why would you want to write those extra, like, so much extra work, right? So here, this is just saying that when we square, when we multiply sine x times sine x, we're actually just squaring the sine at that x. We're not squaring the x itself. Did I explain why the square goes there? Here, we're squaring the 1/2. We're not squaring the 30, right? Okay, I hope I explained that. So what would tangent x times tangent x equal? Anybody? Kate? Tangent squared x. Guess what also that equals? That is also the same thing as sine squared x over cosine squared x. Why? What, Cooper? Oh, the quotient identity? I just couldn't hear you. The quotient identity, yeah, right up here, where tangent is the same thing as sine divided by cosine. So if I square the tangent, then I'm squaring the sine and I'm squaring the cosine. It's equal to something else, too. It's equal to 1 over cotangent squared x, isn't it? Why? Where am I getting that from? Matthew, where am I getting this from? Right here. Tangent u equals 1 over cotangent u, and if I square both sides of the equation, right? Okay. How about this one here? If I have something squared divided by that thing, this would even easier if you had u squared divided by u. What would you have here? U. So if I have cosine squared x divided by cosine x, what do I have? Cosine x. We just cancel out the square. Just like here, you cancel out one of those u's. You're canceling out one of those cosines. How about here? This is what we're going to be doing eventually here today, but also eventually. with this one, what I'm trying to show you is that if I don't want to have a fraction, if I move this cosecant down to the bottom, it won't be cosecant anymore. If I move the cosecant down, if I'm reciprocating cosecant, what does that actually equal? Okay, they're like super loud. Can you say it louder? Sine. Okay. So I can show you one step here. All I'm doing is moving cosecant down and changing it into sine. As soon as it goes down, as soon as it moves from up to down, as soon as it goes down on the denominator, words are hard today, it changes to its reciprocal identity. Is there anything else I could change here? You think I maybe want to change secant? I'm going to put it up on top. What's it become on top? Eventually it does, right? But maybe I didn't want it to look like that. Maybe I wanted it to look like this. What? You guys get how I got this one, yes? How'd I get that one? Say that again? Where's my x over y? My cosine over sine is the same thing as cotangent. So why you would do the thing that I did on top compared to why you would do the thing I did on the bottom, it just depends on what your goal is. I'm just showing you what you can do right now. When we have problems that you have to solve, you might have options. You might have different things you could do, but it just depends, like, what are you actually trying to answer? So these are some identities. There's some more identities on the back here. Except for I haven't given them to you yet. We're going to find them. There's 9 of them. That's what that 9... Actually, there's 1 of them. And because there's 1 of them, I'm going to show you 8 more that you can come up with from just this one. And from just that, there's even more that you could come up with. Yeah. So these are called Pythagorean identity. Why? So we can solve problems that are harder. Well, number 1, it's part of our curriculum, but also we learn this so that when you get, you guys know those like mathematician things where they've got those huge proofs on the board, they're trying to solve the piece of the puzzle and they've got all kinds of math going on. Like you always want to simplify, not that you'd be doing that someday, but you always want to simplify your math, and if there's something that I could exchange, like something I could substitute that makes my math a lot easier, that's why we learn this stuff. So we can do harder math problems, but make them easier on ourselves. So Pythagorean identities. Those are called Pythagorean identities because, let's go back to the unit circle. If I have a triangle on the unit circle, this is x, this is y, this is r, but if it's the unit circle, what is r? 1. If it's the unit circle, what's x? Cosine. Y is sine. So if I do Pythagorean theorem with this triangle, then I have sine squared theta, or u, plus cosine squared u equals 1 squared, which is 1. So this is the Pythagorean theorem written with trigonometry. Okay? Now, I'm suggesting for our second one that we divide, oh wait, I lied. We're going to go down. For our second one, subtract sine squared u from both sides. So I'm using a subtraction property of equality. We're going to subtract sine squared u from both sides, and we have a new identity that says cosine squared u is equal to 1 minus sine squared u. This is a new Pythagorean identity. It's exactly the same as the original. It's just I moved some stuff around. So this is number 2. But you should be able to get number 2 because number 1 is the one that you should know. Sine squared u plus cosine squared u equals 1. Okay, for number 3, I'm going to go back to number 1, but instead of taking away sine, I'm going to take away cosine squared. So if I take away cosine squared instead, then I have sine squared u equals 1 minus cosine squared u. See, we already have 3 of them. I told you there's 9. We already have 3 of them right there. Questions about what I just did? So that was the subtraction property of equality. For the 4th one, we're going to use division property of equality. So I'm going to start with that sine squared u plus cosine squared u equals 1 and just divide everything by sine squared u. And simplify. What is sine squared u over sine squared u? 1. Plus cosine squared u over sine squared u is something on the front page. Cotangent squared u. And 1 over sine squared u is something on the front page. Cosecant squared u. So now we have a completely different looking identity, but it is coming from this Pythagorean identity. So if you ever had, like in one of these problems, you ever had like 1 plus cotangent squared u, and you wanted to make it easier, you could simplify it by putting in cosecant squared u. These are exchangeable. You can substitute with things. That's why we're learning these. We're going to make problems easier. Okay, number 5. Now I'm going to take this one right above it and use the subtraction property of equality, and I'm going to subtract cotangent squared u from both sides. Of 1 equals cosecant squared u minus cotangent squared u. If you ever have like a pretty hard looking problem and it has cosecant squared u minus cotangent squared u in it, you could pull that out and replace it with 1. A lot easier to deal with 1 than it is to deal with all that. Yes, Neil?
How are cotangent squared u and cosecant squared u the same thing?
They're not. But when you find their value at whatever, let me think of a good one we could do.
So then cotangent squared u and cosecant squared u are not the same.
Say that again?
Cotangent squared u and cosecant squared u are not the same.
No, you can't exchange them.
Right.
But if I square them and I subtract them, I will get the number 1. So I could take this entire thing out and exchange it with the number 1, which is what I'm going to show you in a moment once we get through these, is I'll show you how to exchange it. That might have to wait till after lunch, but okay. And then we could also, looking at number 4 up here, I could have moved the 1 instead. I could have subtracted the 1 instead. So cotangent squared u is equal to cosecant squared u minus 1. So I'm just reordering them at that point. So there's 4, 5, and 6. And then for number 7, we're going to go back to sine squared u plus cosine squared u equals 1. And we're going to divide everything by cosine squared u. So if I divide sine squared u by cosine squared u, what do I get? Tangent squared u. That came from the front page for the quotient identity. If I divide cosine by cosine, cosine squared by cosine squared, 1. And if I have 1 over cosine squared, that is secant squared u. So I just simplified each of those fractions, and then we're going to reorder order them for number 8 and for number 9. I can move the 1 over. So tangent squared u equals secant squared u minus 1. Or I could move the tangent squared over, so I have 1 equals secant squared u minus tangent squared u. I've just reordered them the same way I reordered all the other ones. Just look at this. I'm sorry, did you guys copy that down? Okay, I'll just look at this one since it's still on the screen. Look at this one. Is this true? Could we square root? Could we square root both sides? And this would be true. If you're not sure, I can give you another answer that you can totally answer that question with, okay? What's a triple that you know, a squared plus b squared equals, what's a triple you know? 3, 4, 5. So if I had, let me ask the same question using 3, 4, 5s instead of this stuff. If I had 5 squared equals, I'll even make it in order here. Oh, but this is subtraction. It's okay. It doesn't matter if it's subtraction or addition. I could do it with this one over here. I can answer this question with any of them. Okay. No, let me answer with this one. I'm sorry. If I had 3 squared plus 4 squared equals 5 squared, if I square root both sides, is it still equal? Well, kind of. Can I square root and go 3 plus 4 equals 5? Can I do it in that order? Yeah. What's 3 plus 4? Not 5. Can I square root these individual pieces and then add them? Does that work? It does not work. You cannot square root the secant squared and the tangent squared and write that. This one is not a thing. It has to be squared to be a thing. That's going to come up a few times, but I'm going to stop talking because I will lose you after that. We're going to actually see where you use this after lunch. Have a great lunch! Okay, so our example. All of these, with the exception, I think, one of them in your assignment, I think there's just one of them, are going to go down to one value or one trigonometric ratio. So we're going to simplify it as far as we can so it's down to like one thing. I think there's one in our homework that doesn't simplify to one thing. So we look at cotangent, tangent x. What could we possibly switch out so we can simplify? You might need these notes handy if you don't have them memorized yet. What's something that switches with either cotangent or tangent so we could simplify something? Switch cotangent out for 1 over tangent. This is not the only way to do this one. And when we switch out cotangent for 1 over tangent, what happens when we multiply them together? Well, we get tangent x over tangent x, which equals 1. So when I simplify it, my answer is 1. Okay? The next example, cosine squared x plus sine squared x. How can we simplify that? Katie? Somebody? Me? Cotangent what? Oh. No? Somebody? Cameron? You have to look in your packet, unless you have it all memorized. Who said that? Phil? Yeah. What did you say? 1. Yeah. How'd you get that? It is the Pythagorean identity. Look, there it is. That equals 1. Done. Oh, and you guys were all making it really hard. 1. Okay. How could we simplify 1 minus cosine times 1 plus cosine? Ideas. Do we have a 1 minus cosine identity? Is there one that says 1 minus cosine x? Is it this one right here? Does that say 1 minus cosine x? No, this is squared. So can I switch it out? Can I just put sine square or sine, just regular sine instead of sine squared? Am I allowed to square root both sides here? No. Do not do that. That's not how we're going to work this one. Ideas? 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 FOIL? First, outer, inner, last, let's multiply together. I don't know. That could be right. That could be wrong. Okay? If I do that, then what does that give me? What should I do now?
1 minus cosine squared.
Oh, what are you doing, Katie? Oh, the middle two terms, those cancel because these are conjugates, and the middle two terms will cancel. So now we have 1 minus cosine squared x. Is that a thing? 1 minus cosine squared x. Is that a thing? 1 minus cosine squared x. Is that a thing?
Yes.
Sine squared? So I took it and I got it down to 1 trigonometric ratio. It's not an actual number, but it's 1 trigonometric ratio, so it's simplified. Okay? Next one. Ideas? Before I call on you, can I subtract these just as is? What do I have to subtract fractions? Common denominators. That looks yucky. Liam, what was your idea?
Well, 1 over tangent squared x is cotangent squared x.
Okay.
But that's also equal to cosine squared x over sine.
Oh. So if we're going to do that, what should we do on the other side? Just leave it as 1 over sine squared x? Is that where your brain was thinking?
Yeah.
Oh, okay.
And then you have a common denominator.
And now we have a common denominator? Okay. And if I have 1 minus cosine squared x over sine squared x, what is 1 minus cosine squared x? I feel like we just did that. Okay, so I would have sine squared x over sine squared x, which is 1. That's not the way I would have done that one. FYI. However, that way works. There's not a one-size-fits-all type thing. There's not a one way is the way you do it. You want to see how I would have done it? So the way Liam started out by saying cotangent squared x, I did that, but I did it with the sign also. I've changed it into cosecant squared x minus cotangent squared x. And that is right here, which equals 1. So both of those ways work. You might not always pick the shortest way. That doesn't mean you can't persevere through and get to the same answer. Okay? So I'm glad that you picked something that I wouldn't have done, because now you guys got to see 2 ways of doing it. How about cotangent x times sine x? What can we do? We're going to simplify this. Matthew, you got an idea? Is there anything equal to anything else up here? Cotangent x equals something different, or sine x equals something different that might make sense on your front page?
Cotangent equals 1 over tan.
Okay, so if I change that to 1 over tan, Is that helping me get it simpler? Maybe. Maybe not. What do you think, Corey?
Cosine x is equal to cosine x over sine x.
Okay, so instead of using the reciprocal, she's using the quotient. And if you use the quotient instead of the reciprocal, what happens to our signs when we multiply straight across? We get cosine x. It's okay to choose, well, it's not like a wrong answer. I actually could show you how to get it there from 1 over tangent. I can show you how to get it there, which is probably not the fastest way, but I could show you how to get it there too. Want to see? You've asked. Now I want to show you. It was 1 over tangent. If we went with what Matthew said at first, if I did it this way, I'd have sine x over tangent x. And then I might say, well, tangent is sine x over cosine x. And then I might say, instead of dividing by a fraction, what could I do? Instead of dividing by a number, I could take sine x and multiply by the reciprocal, cosine x over sine x. And then those cancel and we get the same answer. So you can get there from either method, just one of them shorter. But you won't know until you try it yourself. If you sit here and you don't actually try to answer the questions as we're going through it, you are not going to be able to do it totally on your own. So as I'm throwing it out there, I'm not telling you answers, I'm asking for help. Actually go and look in your packet. See what maybe you'd try. How about this one? 1 minus cosine squared x over sine x. Go look around for stuff. Call on somebody at random. Who will it be? Oh, it's totally going to be Aliciana. Hi.
For the first one, you can use sine squared.
On top?
Yeah.
So that's a thing? 1 minus cosine? Oh yeah, didn't we just do that like 4 times today? Okay. So sine squared x over sine x. And then what happens? Kate? What cancels? Sine x. One of the sine x's cancel. So we end up with just sine x on top. Because one of them cancels from the top, the whole bottom one cancels. We get sine x. Next one. I'm going to call on somebody for an idea. It might be a different idea than I'm thinking. We'll see. I'm going to call on someone. Jalen. What are your thoughts? What are your thoughts? Okay, so if we have secant squared x times cosine squared x. Oh, how did it do that? I thought I got it in time. All right, so if we have secant squared x, and then he said take 1 minus sine squared x and change it into cosine squared x. What should we do now, Mike? Okay. Change cosine squared x into 1 over secant. That's what you're saying, right?
Yeah.
Okay. And then we're going to multiply straight across, and what are we going to get for our answer? Cooper? 1. Were you guys thinking make 1 over secant, or did you think something different? Amelia?
I was just thinking of 1 over cosine.
Right, that's totally what I thought he'd say, and then he surprised me when he said that, but both work. Both work, so. Totally fine. Okay, next one. Oh, I'm going to call it on randoms. You guys put your hands down. See who's been quiet today. See if they're paying attention. Morgan! What do you think, hon? And you know what? When I call on you, you don't have to have the entire thing worked out. You might just have like one idea. And we can go off of that idea. Morgan, do you have just one idea? Okay. Do you know what cotangent equals? Front page. Can you say it a little louder, huh? Oh, okay. So cotangent is cosine x over sine x. So if we change that, do we now see maybe a path? If we change just cotangent, we don't have like the whole direction that we're going possibly yet, but I know that cotangent is cosine over sine. Do you see how these signs are going to cancel? So what happens if I'm left with cosine x times secant x? What could I do now? Jillian? If I have cosine x times secant x.
1 over cosine x is the same.
Okay, so I could have cosine x times 1 over cosine x. And what's going to happen? And we'll get 1. Oh, no. Oh, man. What do you think?
You can like mix the properties together. Like,
Yes.
you don't have to have, like, a single one.
Right. That's why we're doing a bunch of examples so you can see ideas.
What do you mean you can use the properties?
Well, like, what were you thinking? Like,
For like the first one, like when she did cosine like over sine, that's the quotient.
but then over here was the reciprocal, right? And I could even use the Pythagorean, not for this one, but I could use a Pythagorean in there. Like, you can just, anything that's an identity is substitution. You're allowed to substitute. But you always have to follow math rules. That's where people get in trouble, is they don't really know their math. They know tricks and gimmicks and things, but they don't actually understand the math. So that's where we get into trouble in some of these things. Just saying. So that's when people have trouble, is when we don't know the math. Like, do you know how to add fractions? We're not doing it, but do you know how to add fractions? If you don't know how to add fractions, you're going to have trouble with this section. Okay, let's look at this one. What do you think? There's some ideas out there. Katie.
If we do the minus CSC, yeah, that one over sine.
Yeah, change this right here into 1 over, oops, put the parentheses. Okay, so I'm going to do that, but I'm going to write it, I'm not going to actually write the 1 over sine. Watch how I write it. Because this is one term, and all I did was move the cosecant down to the bottom of that term. I moved it from the numerator to the denominator and changed it to sine. So I'm not actually writing it as 1 over sine. I've already, like, in my head done 1 over sine and multiplied them together. But yes, that's what you said to do, right?
And then whenever you get the sine,
Sine squared x minus 1.
that would use sine squared x.
No. Sine squared x minus 1 is not cosine squared x. Oh, no. Is there a way, like, is there a way, let's go up here. Is there a way up here to make sine squared x minus 1, just from question number 1, or identity number 1, is there a way to make this say sine squared x, or u, minus 1? Is there a way to make it say that?
Yeah.
What could we do?
Subtract the sine squared x from both sides.
No, that's going to make it this one. How can I keep the sine squared x here?
Subtract the 1 and then subtract the
If I subtract the 1 and I subtract the cosine to the other side, that's going to give us sine squared u minus 1 equals negative cosine squared u. So that's, again, using these identities to form even more identities. So that should be a negative cosine squared x. Did I lose anybody on that one? Sine squared x plus cosine squared x equals 1. Subtract 1 from both sides. Okay, and then I subtracted cosine squared x. So sine squared x minus 1 is equal to negative cosine squared x. They're equal. I'm just using properties of equality to rearrange the equation. All right, one last one. What do you think? Oh, question? Use this for is not really what we're doing today. Utilize this for something else. Okay. The goal is to get it down to one trigonometric ratio, one. But tomorrow I'm going to tell you this equals 1, and you have to show me the steps. So these are just like, this is a way to learn how substitution works with trigonometry. Okay, this is a procedure to help you get better at trigonometric properties, and that way you can apply it to harder stuff at some point. But the only day that we're going to do simplify is today. I don't know if I answered that question. So would it be wrong if you left it here? Yes. It wouldn't, because I could still simplify something. That's just like if I tell you to simplify. Yep. If I tell you to simplify here, if I tell you to simplify this, and you say, oh, well, that's 6x plus 3x plus 1. Would that be wrong? If I say simplify it, would this answer be wrong? Why, Dylan? Because I still can simplify something further. 9x plus 1. Like, this is the better answer, I should say. So this answer is okay, but this is the way better answer. So it's kind of what we're doing here, only it's with new stuff. You've never done it before. This last one, what do you guys think? Where could we try? Where could we start? Who's got an idea? Dylan Reams, you got an idea? Okay, so sine x times sine x over cosine x plus cosine x. Okay? Sure? Same if I do that, what should I do next?
Would it become sine?
Sine, not 2x, sine. You don't. Squared x. Because sine 2x is something different. I just want to make sure. Over cosine x. Sorry. Plus cosine x. All right. We got to here. Should be able to simplify this further. Ideas? Liam? Okay, so what are you doing right now? Like, why are we... So this is a value of 1. Okay. So I have I ran out of space. Sine squared x over cosine x plus cosine squared x over cosine x. So now we have common denominators. I have to go somewhere to finish this problem. Sorry, guys. Okay. So I keep denominator. Add my numerators together on top. Sine squared x plus cosine x. Actually, that looks even more complicated. We're trying to simplify it. But I know we're on the right track. I know we are. But I know what we could do now. Simplify is the correct answer for all of these questions. How can we simplify? You do that, you're going to get a lot of these wrong. So you cannot cancel over a You're only allowed to cancel over division. That's another problem that people have when we do this stuff. You guys see what she's saying to cancel these? You can't do that because of this nasty addition sign. Matthew?
Isn't sine squared x plus cosine squared x?
Yeah, it is. During identity, it says this is now 1 over cosine x. Still not done. I'm going uphill, though. It's weird. I can go one more step. Secant x, yeah. Got it to 1 trigonometric ratio. So that's what our assignment's going